All right, lesson 74, geometry, reflections. We're going to talk a little bit, this is again, goes back to that first introduction lesson that we covered, which was introduction to transformations. We have three types of transformations. Can anybody tell me what those transformations are? Rotation, reflection, translation, right? And the reason we talk about those three, it's not that there's not another transformation that we'll talk about, which is dilation later, but these three share something in common. Does anybody know what those three transformations share in common? It really comes down to something that all three of them don't do, and they don't increase or decrease in size. There's no change in size or shape. Okay, they're isometric. Okay, the corresponding sides are going to stay the same length. The corresponding angles are going to have the same measure. So here we have a definition here. It says reflection is a transformation that reflects every point in a figure over a given line. After reflection, the image of the figure is congruent to the preimage, but it will have a different orientation, and that's how it's different than, say, translation. Okay, so we're going to be oriented differently. In fact, translation is the only transformation that we talk about where the orientation does not change. Okay. We have some properties of reflection. Darian, can you tell me about at least this property that we see up here? At least read that out for me. Okay, and then beyond that?
The reflective point across a horizontal or vertical line image that imagine that the line is a mirror and visualize the reflective.
And this is fine for being introduced to it. This second statement is this whole imagine and visualize, but there actually is a mathematical component to it that we're going to look at later in terms of measuring distance and checking on slope and making sure that we're perpendicular to our line of reflection and that we're going, our line of reflection should be a line that's equidistant to either point, right, to points on both sides of the line of reflection. For instance, if you were to look in the mirror, as you step closer to the mirror, your reflection steps closer to the mirror. If it doesn't, you need to get out of that house. Okay? If your reflection does something different than what you're doing, right, you're in a horror film. All right? Something weird is going on. All right? So you move to the right, it's going to move to your right. You move to the left, it's going to move to your left. Your mirror is going to stay perpendicular to you, okay, to you and your reflection. And it's always going to be the midpoint between you and your reflection. All right, so those two things are true. I don't know that they necessarily go into this lesson, but two things are true, is that the line of reflection is always the midpoint and is perpendicular. Okay? All right. Let's see if they give us anything else here. Notice, and we'll pull this up so that we can see it, when a point is reflected across a horizontal line, its x-coordinate does not change. When a point is reflected across a vertical line, a lot like the y-axis, its y-coordinate doesn't change. Okay? To find the reflection of a point across any line in the coordinate plane, we draw a perpendicular line from the point to the line of reflection. The point's reflection will be an equidistant from the line of reflection on both sides. Let's see. Let's look at this here for a second. I'm going to draw just a really basic coordinate plane. Okay, we got something like this. If I've got just a single point here, all right, let's call this, coordinate 2, 1, and I want to reflect it across the y-axis. Okay, the y-axis is going to stay. Right, it's going to be the midpoint, which means I'm going to go the same distance across the y-axis as I am from it right now, which means I'm going to go 1, 2 to it, which means I'm going to go 1, 2 across it. All right, but I'm going to stay right there. All right, so what you'll notice about the change here is that I'm at -2, 1, which means when I reflected across the y-axis, the y value didn't change, but the x value became the opposite. Okay? So we can actually write a rule for this, is that whenever we're reflecting across the y-axis, our rule looks like this. that we will get negative x, y. My x will become the opposite sign, my y will stay the same. Okay, that's my rule for reflecting across the y-axis. And again, that's not something that this lesson gives you, but I'm going to give you, it'll probably give it to you later. If I introduce it now, we won't have to spend so much time on it later. Does this make sense so far? Okay, now if I want to reflect that same point across the x-axis, all right, that means that my x-axis is my line of reflection. I'm going to go down the same distance that I am from it. Okay, so we go down 1, which means I'm going to go down another 1. All right, I'm going to keep that x-axis as the midpoint, and we are moving perpendicular. Okay, if I look at this, my coordinates are 2, negative 1, which means my rule for reflecting across the x-axis is that my x value stays the same and my y value becomes the opposite. Okay? If I was going from my red dot to my black dot, we would still use that rule, right? Negative 1 would become positive 1. Okay? You guys all seem super excited about this. Great. You guys are always so encouraging. Okay, let's look at some of this. All right. So we have an image at coordinates 2, 2, 3, 4, and 5, 2, and we want to reflect across the y-axis. All right, the first thing we have to do is actually plot the points of the pre-image. So we're going to go to 2, 2. Okay, that looks good so far there. 3, 4. 3, 4. That's right there. That doesn't look like that's going to work. And 5, 2. Right, so my pre-image should look like that. A is obviously wrong. But does it look like C's pre-image is correct? C's pre-image is correct, and we want to reflect across the y-axis. So we're looking at each of these individual points. Now, if I keep in mind reflecting across the y-axis, we should be able to write what those coordinates are going to be. Remember, when I reflect across the y-axis, the x becomes the opposite, and y stays the same, right? So what should the coordinates of 2, 2 become? Negative 2, 2. And 3, 4? And 5, 2. Okay, so we could just real quickly graph and see if these come out to the same spot. Negative 2, 2. Negative 3, 4. Negative 5, 2. All right, so is that successfully reflected across the y-axis? Yeah. Right, and we could count, see how 2 is 2 across, it's going to go 2 across. This is 3 across, it's going to go 3 across. This is 5 across, so it's going to go 5 across. Okay, keeping my y-axis as the midpoint in the line of reflection. All right. Triangle EFG has vertices at negative 3, 1, 1, 1, 4, 5. We want to find the coordinates of point F after reflection across the x-axis. So we don't need to find out anything about E or G. We just want to take 1, 1 and flip it across the x-axis. Whenever I'm reflecting across the x-axis, does the x value change? No. What happens to the y value? All right, so what are the coordinates? 1, negative 1, okay? See, it works out right there. See how much quicker that is when you have a rule? And again, as I look through the book, they do give you the rule, but it's kind of hidden. You'll find the rule for this. You'll find it in example 1 as part of the solution, and in example 3 as part of the solution. But they don't, I really feel like they should have given it a separate section where they should have bolded it and said, hey, here is this rule. You can use this every time you're reflecting across these axes. They didn't do that. Okay. This one's a little bit of a different question, and I've had this question on tests. I don't know that I'll keep using it as a test question because I feel like it's a little out there. It says, in miniature golf, Amanda wants to hit the golf ball, which is our white circle, into the black circle. She wants to accomplish this in one shot. Which statement best describes what she should do? And so I'm going to kind of tell you what they're expecting. And I don't know if this will help you with your golf game or not. But what they're saying is that we want to use line L as a line of reflection. Okay? And again, I don't know if this actually works in golf because I'm not a golfer, but we're going to reflect our ball across that L. So, if we're just approximating the distance, we'd be somewhere about there, right? Okay? From there, what I would want to do is draw a line from there to the hole. And now I'm going to look at where this point is, and I'm going to shoot for that point on the wall, and that should bank it into the hole. Okay? Which, I don't know. Now that you know this, you can now go to your miniature putt-putt course with a ruler, maybe a tape measure and a protractor, and you can just school some folks because you know the tricks, right? So your answer here is A. It says, find the reflected image of the golf ball across line L. Draw a line connecting the image to the hole. This is our image up here. Mark the intersection of the line with the line L. Amanda should aim her stroke for this intersection. So again, I don't know that this is anywhere in this lesson at all. It's kind of a goofy question, but there it is. Okay? Do you feel enlightened? I hope so. All right. Let's see. Next question, number 4. Which of the following is a mapping notation for a transformation of a reflection across the y-axis? Well, I've already given this to you. So if we're flipping across the y-axis, what happens to the x value? Nick? Becomes the opposite. What happens to the y value? Stays the same. So is there an answer up here that matches what you've told me? A. Good. All right. So pretty easy stuff so far. Okay, come down here. I think we're on our last 2 questions, something like that. All right. In the diagram below, we want to reflect triangle DEF across the y-axis. Find the coordinates of the vertices of the reflected image and write the transformation mapping notation. So notice that one of our points is actually on the line of reflection, right? Now, again, kind of go back to our illustration, which is how mirrors work. Have you ever touched a mirror? Okay? When you touch a mirror, who else is touching the mirror? Your reflection is touching the mirror, right? So your finger is if you're touching with your finger is at the point of reflection, which means the reflected position is also at the point of reflection. So if you have a coordinate point that is on the line of reflection, it doesn't move. It is both the image and the pre-image at the same time. Okay? So then we have to decide, okay, this is really, I'm going to get some volunteers for this. Right? Let's see. Aaron, can you come and put F? Can you reflect F across the y-axis? Across, okay. So here's F, and here's my y-axis. We want to reflect it across the y-axis. You successfully reflected it across the x-axis, I believe. A little closer to the y-axis, because let's look at the distance that this is from my line of reflection. Well, okay. So this is on line 1 going this way. So we're going to be on line 1, perpendicular over. Here, let me actually get you perfect. That's it right there. Oh, sorry. All right. Now, let's see. Can I get somebody, now that Aaron's done all the hard work, can I get anybody to do coordinate D? I think Matt looks like a really strong candidate for this. Matt, can you put coordinate D across the y-axis? There you go. Okay? I mean, so it's a pretty small dot, but we'll make it a little bit bigger there. All right, and then we just got to connect those points, and we should see it's pretty close to being the same thing. Okay? Very good. You did it. All right. So with reflections, the most important thing first is determining what your line of reflection is. Okay? With rectangle ABCD, it says it has these given vertices at -2, 1, 4, 1, C negative, or 4, -1, -2, -1. We want to reflect across line y equals -2. So this is, let's see, I don't know if I still have this up or not. I don't think I do. I'll see if I can find one real quick. Let's see. If this will let me write on this or not. Okay. It may let me write on this. All right, so hopefully we got that, and we've got our coordinates. So let's go ahead and graph our coordinates. We've got -2, 1. So we're going to go -2, +1, something like that right there. We've got 4, 1, 1, 2, 3, 4, 1. We've got 4, 1. Oh, we've already got that one. 4, -1. And -2, -1. So I've got that little rectangle right there. The next thing that I need to graph is the line of reflection. The line of reflection is y equals -2. Okay, y equals -2. Okay? Y equals -2 is what kind of line? Is it horizontal or vertical? We tend to think that because the y-axis is vertical. The y-axis is actually the line x equals 0. I know that's confusing. Okay, so it's actually a horizontal line. Okay, so I'm going to put that in red here. -2 is actually this line right there, and I want to reflect across that. Okay. All right, so it's different. We can't go to the rule on this. So I actually do have to just look at it, right? And I'm going to get this coordinate. We're going to go down to, okay, a little further, okay, until I get something like that. Does that make sense? But the difference is that this coordinate is here, 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 and here. So those positions, those new primes, aren't just, they're not in the same orientation as they were. Does that make sense? All right, so where A was -2, 1, okay, that's -2, 1. This is A prime. Okay, 4, 1, okay, which is B. This is B prime here. Okay, then we had 4, -1, which was C prime. So C prime goes all the way down here. That was C. C prime is down here. And then finally we had D prime. D prime is right there. Okay. They will get more complicated when we start talking about lines of reflection that have a slope to them. Okay. If they give me something like y equals x, right? Y equals x is actually this line right here. So if they give me a point there, and I need it to be perpendicular, right, I actually have to find a perpendicular slope to that line and go that distance across. So it's a little bit more complicated. All right, but today they're keeping it fairly simple. I think your assignment, I might have shortened it up a bit, so I'm not sure exactly what's on your instruction sheet. So I'm going to stop this right here and let you guys get to work. I think you guys actually have a pretty good amount of time to